Yeah, greetings everybody, and welcome to lesson 2 on enthalpy, energy, and change. Okay, so for this lesson, I want to start by giving you a summary. Okay. So I like to make this tabulation. Okay, just to make things clear and to make it clear about the differences between endothermic and exothermic action. Okay, so now here we're going to have the type of reaction. Okay, and then so the types, we have two types. We have exothermic and we have endothermic. Okay, and then so for the second row, we're then gonna have so energy absorbed or released. Okay. Um, okay. For exothermic is released, for endothermic it is absorbed. So now let us, and then the third row is gonna be mm, so now here we have relative energy, yeah, of reactants and products of uh, let me redraw this, make it straight line here. Relative energy of reactants and products. So now, for an exothermic reaction, we say what? Energy of reactants greater than energy of product. Yeah. And then now for the endothermic, it's the other way around. It's energy of reactants, energy of reactants less than energy of products. Now, the last one is what? Is the sign of the sign of enthalpy. So we say it's negative here or less than 0. And then for the endothermic, the sign of the enthalpy is positive. That is, it is greater than 0. Okay. So this is a summary of the two reactions. Is the exothermic and the endothermic. The exothermic, the energy is released, and then endothermic, the energy is absorbed. Okay. So, and then the sign of the enthalpy for the exothermic, it is negative or less than 0, and then it is positive or greater than 0 for the endothermic. And then we say the energy of the product greater than the energy of the products of the reactants, I mean to say, is greater than, here is less than the energy of products. Now, okay, let us do an example here, okay? So let's do an example. So I have an example here so that I can show you typically how questions are asked. Okay. So an example here, they say what? Refer to the graph below. refer to the graph below. Okay. Refer to the graph below. And then answer the questions that follow. So they gave us a graph here. We're given a graph. You have the time? So and then they gave us 3 values. Okay. So we have a potential energy on the other side. So it's 103. It starts there. And then we have 103. This is how it goes. So now the reactants begin here. The reactants begin here. Then the graph goes up to 103. And then it comes down. And then it will go flat at this point. So this side you have the what? Potential energy. Potential energy, and then the unit they give a unit to this side. They say kilojoules. Okay? And then there are 3 questions. There are 3 questions that they ask. They say we must calculate delta H to is the reaction endothermic or exothermic. Then they say give a reason. For your answer. And then number 3, they say must calculate the activation energy. The activation energy, calculate the activation energy for this reaction. So let us look at what? Let us do solution together. When we look for delta H, okay, the delta H meaning the enthalpy of the reaction. What do? Need we look for the energy of the product, E minus E reactant. Now, okay, we must look at the the graph, okay, because we know that the reactants will be here where the graph begins, okay? And then the product is where the graph ends here, okay? So if we say products minus reactants, it means we're going to say 10 here, and then we subtract 45. So it's going to be 10 minus 45, which is going to be equal to negative 35 kilojoules. So that is the enthalpy of the reaction. And then they're asking, is the reaction endothermic or exothermic? And then they say, give a result for your answer. So it is going to be exothermic, okay? Why? As it has a negative enthalpy change. It has a negative enthalpy change. That is why we say it is that's why we say it is exothermic. The activation energy, okay, E activation will be equal to E of the complex minus the E energy of the reactant, okay? So at the complex is where is at the activated complex. The activated complex is at the top, see? So it's gonna be so the energy of the what? The activated complex. Where are we gonna get it? On the graph, okay? We go to the graph. We look at the maximum, okay? We look at the maximum point here. This is the energy of the activated complex. This is the energy of the what? Of the reactants. So 103 minus 45. Okay. Then it's going to be 58. So, okay, now let us look back at the what? At the second. Okay. So, an alternative answer here for what? Number 2. Okay. So, option 2, isn't it? Option 2. So, for number 2 here, you could say it's exothermic. Okay. And then another reason could be what? Another reason here, besides the one that we gave, you could say this is because what? Energy of the reactants is greater than energy of the product. So this could be another explanation. Yeah, you could say you could use the enthalpy, or you could say this. Okay, this is just uh, another way that you could explain your answer here. So it could be one way or it could be the other. It doesn't have to be both. You see? Okay. So let's leave it here for lesson 2. Let's leave it here for lesson 2. We will do more examples. So for lesson 3, I'm going to do an exam type question. An exam type question, so you can see how the questions with regards to this topic are asked in the exam. Okay. So thank you for tuning in. Thank you for tuning in into Math Zone African motifs. And I hope you tune in for lesson 3. Thank you. Bye bye for now and take care.